Well, the idea is to talk about test-driven development and unit testing. We need to start creating unity testing on our components. It's a must-have. We need to do that. It's too important so we can improve the quality of our components, our code. We can do mesh faster, and this is too important thing to a mature team. So we are starting with this strategy to implementing unit testing in our components. And Kabir will talk to us about test-driven development, and I will talk to you when we can discuss guidelines and frameworks that we can use to do unit testing in our code, in our components. Right, Kabir?
Yes, so actually it won't be test-driven development, it will be what I call simple philosophy of testing, and that's probably
Okay.
not philosophy of testing, but pretty much my philosophy of testing. So we'll
Uh,
start kind of understanding how I look at everything and what is basically behind all this what we're trying to do with testing and environments and stuff like this on a very kind of general basis, because I mean, we jump into the categorization of what is unit test, what is functional test, what is acceptance test, whatever, which basically from that side is pretty much arbitrary labels that, but there is a reason to call them that way. So let me just, maybe I prepared small presentation.
okay.
So let me try to do it. Sorry. I have to do it with without presenting notes here. So basically, we spent some time. Some of you maybe saw trying to build our environment of testing, and when we started with CI/CD pipeline, and then we went into the testing environment. The kind of complexity of our case compared to probably most of the projects is that we are running this decentralized network, and many of the errors of the behaviors are related to the fact that we run a bunch of different nodes which communicate with each other, and communication, as always, it brings in aspect of uncertainty and basically unpredictability, but nevertheless we have to test that anyway. So the whole, let's say, picture is that, so from the left we have all the imaginable possible scenarios that can be, I mean, it's a basic kind of testing yeah, simple philosophy, let's say, that we have all the possible scenarios, which is, I mean, it's driven as a cloud, but actually it's unknown. We don't know what people can do on a complex, how people can interact with a complex piece of software, hardware, and the platforms that we are projecting. Now we have in the middle the blue, so the left hand is possible scenarios, which is a bunch of stuff which is unknown, it's growing, and we are trying to figure out what are they. Another, and these behaviors, or possible behavior scenarios, they get hit into the platform, which is piece of software which we are building, and then out of there we get either desired behavior, something that we predicted that will happen, and we also get undesired behavior, something that we unpredict. Well, we're not able, but we know that it's undesired only when we get it happen. Before that, we basically do not know it. So the red one on the right. So the kind of complexity here is that we do not know what are the all possible scenarios. Let's start from the beginning. So the end of it is that we want the desired behavior, which is a green blob, to be as big as possible. And we want undesired behavior, which is a red blob, basically non-existent, but we know that that's not possible. Therefore, we try to minimize red and maximize the green. However, we do not know the possible scenarios on the left. It is unknown. It can get known only by exposing the platform to the real environment. And of course, we can try to kind of design stuff, but or design and to figure out what could be those scenarios, etc., etc. It doesn't mean that we shouldn't do this, but the main and that's kind of the let's say philosophy of test-driven development, or rather experimentation, that you basically build something that you have certain understanding what is the desired behavior, but then as soon as possible you expose it into the more or less real environment, and then you get to know what could be possible scenarios, and you start to define more the left block of possible scenarios. The complexity here also is that we are constantly developing the platform, which means that the, let's say, vectors of, or let's say, amount of possible scenarios is also increasing all the time. It's not that it's only unknown, but it's also increasing. Therefore, the only thing that we can do, we expose it all the time into as real environment as possible, to get to know what are those possible scenarios, and to tend them and to see whether they produce desired behavior or undesired behavior. So actually, the desired behaviors, the green blob, they define what is the functionality that we know about the platform. And as I said, all these behaviors depend on the non-deterministic, I mean, the mapping between whether certain scenario, certain behavior from the left go to desired and undesired behavior. It depends on the quality of the code, but also it depends on the kind of non-deterministic effects of the fact that we're running decentralized network, where there are a bunch of stuff which we don't control, like hardware, like whether it's connected to, I mean, which NATs, etc., and so on, so forth, which we also learn by exposing the thing to the environment. Pretty much in this environment, what we want, as I said, we want to increase the number of detected undesired behaviors constantly, because the whole thing is always changing. Then detect them as early as possible in the process, and this is something that I will say why we want that in the next slide. Then we want to figure out why those undesired behaviors happen, and where in our stack, in the platform, they happen. The kind of another complexity here, that certain undesired behaviors may be triggered by the use cases, which will not be built in the future by us, but by third parties. But let's leave it for now. And in order to get to know where those undesired behaviors happen, and further why they happen and to correct them, we need the developer tooling. And developer tooling in the kind of, well, let's say usual environments, but that's usual, it's kind of changing, is that you have debugger where you can run on your machine sort of step functions, etc., and to see what each line of code doing. In our case, it's kind of slightly more complicated, because a bunch of undesired behaviors will happen when during the communication between independent pieces of hardware, software, where you basically, and all kind of messaging, delays and timeouts, etc., and so on and so forth, where you cannot really run this type of, let's say, debugging. One way or another, this is where developer tooling comes in, that we have to build, not only for us, first of all for us, but also for whoever will come and build use cases and business models on top of the platform. So what we want next, we want to correct those undesired behaviors and basically turn them into the desired behaviors, because this means that there will be certain scenarios, etc., and so on. And the last step is ensure that this kind of undesired behavior, let's say that this possible scenario, we identify that it creates undesired behavior, we turn this undesired behavior into the desired behavior, and then we make sure that this scenario, when it happens again in the next version or whatever in the future, it doesn't trigger all this undesired behavior again, which, simply speaking, we put that thing into the test suite. So given all this, we have to, so from my perspective, actually, To simplify things, let's say, I kind of don't care whether it's unit test, functional test, user acceptance test, or whatever test we say. What we care is that we have only desired behaviors and we don't have undesired behaviors. So the kind of splitting them into these types of tests, etc., it's already a technical question. How do we do this efficiently, and how do we manage the whole process so that we build procedure, how to define the possible scenarios, how to log them into test suite, and how to actually run each version of the platform and detect those behaviors as early as possible. So regarding the early as possible, because basically we can detect it, in principle, we can detect it on the real network, except that if we detect it on the real network, then we crash the network, then the whole testing doesn't do this job, which means another one, let's run two networks. One is real network just for testing. Another one is real network for production, which gives us, let's say, the whole environment to which we want, the whole complexity of the complexity of the full complexity of the environment to which we want to expose our code in order to get all the, let's say, types of behaviors and to categorize them whether they are undesired or not. However, this is huge and heavy and kind of technically not very possible. So the real environment is huge, heavy, etc. But we want to catch those undesirable behaviors early because for several reasons. If we catch, let's say, error one month after the code was written, we will simply forget how it was written, and we will write a bunch of code on top of this, which will complicate solving it. So we want to catch those undesirable behaviors as early as possible. However, as I said, certain environmental influence on the software can be triggered only by pretty much real environment. So therefore we have what we call environments, like different types of environments where we simplify the environment. So on the left here, let's say it's a real environment. So the green kind of dot there, let's say it's actual real environment, and it really exposes to everything that we can get from there. However, this is production. We want in this place already to have code which minimizes undesired behaviors. In this place, what we want is actually error handling more than the testing, so that errors do not kill the whole machine. We have a way for the errors to propagate and to know them and to kind of reboot. That's another question. But close to that is staging, where we want to have as real environment as possible. However, it's not a production, where we can expose the platform that is close to, let's say, pre-release stage, to all kind of behaviors that can come out of the network. Plus, we want to have all the behaviors which we observed beforehand. As I said in the last slide, we want these ones automated. And in the staging, so here, I'm moving from the real environment to the right, which is mock environment. Actually, it's not very clear what's written, but it's moving from the real environment to the mock environment, simplifying those environments so that we can build tests as soon as possible, to test things as soon as possible and as efficiently as possible. So we build environment. So the goal is to run tests which need a simple environment on the simple environment, which allows us to run them more efficiently, more often, and to catch those, let's say, simpler bugs, or to simulate simpler behaviors earlier in the process. So I'm moving a little bit from the complex to the simple. However, in the actual testing, we will move the other way around. We will move from the simple to the complex. But so maybe let's try to do that. So from the right, we have features, where feature means there is environment and the stages of the testing, which we will run on a simple, like, small network. Before that comes unit tests, which don't need environment, which will run only on GitLab. But basically feature. So there's a small network which kind of has few machines, which at least exposes some sort of communication between machines. in principle, but it doesn't expose to the whole complexity of the network. Then from there, so this is on the right. It's a kind of black one. The big square is kind of our server. The development environment is this black thing plus certain machines which will be, more machines from the community developers which will be dedicated for testing. And since hopefully this will give us more exposure to the kind of complexity of the environment, therefore we'll be able to test more things. But since it will be more heavy and it also will involve community members where we'll have to manually, we will not be able to automatically run this because we will have to tell people to update their machines in order to join the network. So it will involve communication with the developers community that we're building now via Discord server. So that's another stage. However, we want to catch more, let's say, bugs here. Not even bugs. Is to simulate, to get more understanding of what is possible behaviors and whether they produce desired effects or undesired effects. And staging is, ideally, it's like a replica of production network where we can simulate each connectivity, each device, each operating system, and basically all the scenarios that may happen in the production network. I understand that that's not possible. And also, we will involve people there to test things manually because people are wonderful for doing all kind of stuff which is unpredictable. The goal here is actually when we find this sort of stuff, as I said here, at possible scenarios which was not predicted by us beforehand, we want to make it automated and include in our, let's say, lower stages which can run on simple environment. And the production, we cannot rule out the bugs in production on undesired behavior. That's the nature of things, but we want to have error handling there. And then, so what we do, we invent stages of testing, which is unit functional acceptance. We see which tests are running on this environment. We build those simplified environments as I now presented in order to run those tests, and then we map tests with environments. This is something that we were working. I think I will show basically this matrix that we had. Okay, what do we have? Yeah, let me show it here. Just quickly, as an introduction. So basically, we make a matrix of tests and environments, and we figure out on which environment we run which tests. And then we come to basically the CI/CD pipeline where we have static analysis that runs on every basically merge request, but it runs on via GitLab. We do unit tests, which runs again like statically on the GitLab automatically. Then we have security tests, etc., etc. Then we have builds, we have functional tests. It's already a question where we want to run it, but the point is let's say the line of truth is here between staging and production. We want to catch all possible, whatever we know, whatever we don't know here. Now, when we catch it, then we figure out into which environment and to which test we can build it in order to catch these things as early as possible. However, that's it. So this is something that I wanted to say. All this logic of unit test, static test, etc., it's not defined somewhere in stone. We have to kind of, at least I would like to kind of convey that we want to position those tests with a general philosophy why we are running them, and that relates to unit tests and the need to do unit tests. The thing is why we want to start, because we still do not have the whole pipeline running, but we would like to get this whole pipeline running as soon as possible and then start building backwards. However, until we have the whole pipeline running, we already can start building unit tests, which needs only part of the pipeline. So that was a small kind of digging deeper, but the main thing that I wanted to say is basically this, this kind of picture of the philosophy of general why we're doing testing and what is the overall goal. So That would be it from my side. Thanks. Anyway, if you have questions, and if we have time for questions, as always, I spoke too much, but that's it.
Okay, thank you, Kabir. So, Kabir, tell us about the general idea of environment and tests that we'll be doing on that environment. And Kabir show the stage that we'll be constructing on our pipeline. And one of the stage is unit test, and I will be talking about that specific stage, okay, unit test. But as Kabir told us, we will have more testing, more stages for testing in different environments. But now we will be focused on unit testing because we need to implement unit test and automatize it using the pipeline. Okay, the idea is that every measure request that a dev push to GitLab, it needs to have unit test. Okay. I'll be showing one slide with definition, one with objectives, one with technique, and 3 slides so we can discuss about guidelines, and I will try to show a real world example using some files on SNAP GitHub. There is a concept of testing driven development. It's a software development process relying on software requirements being converted to test case. So the idea is to have test case to each requirement. And this is a development driven for this test perspective. Okay. And one aspect is unit testing. What is unit testing? Is a way of testing a unit. What is a unit? Unit is a smallest piece of code that can be logically isolated on the system. This word is too important, isolated. This test needs to be isolated. And what is a small piece of code? For instance, in Java, it usually is a class. In Python, it's usually a file. So we need to have a test for a class and a test for a file to test that API inside the class or in a Python file. Okay, so usually we have a test that tests all the functions and methods inside a class or inside a Python file. This unit test, it doesn't run on a live environment. For instance, we don't need to have the DMS running or the adapter running to do the unit test. Unit test is done without the environment running. Okay, we have frameworks. We code these unit tests, and we run a framework to run these tests in an environment that's not effectively running our code. And the objectives of unit testing is to verify the correctness of the code and to fix bugs early on development cycle. This is cheapers. Another another objective from using unit tests is to help developers to understand a code better. If we need to see, to work, to use a code from another, did by another developer, the test is help us to understand what that method or that function need to do. And this helps the code reuse, of course. So the main aspects of doing unit test, we need to keep in mind that each part needs to be tested individually. We are not testing the workflow of the code. We are testing parts individually. We need to isolate sections of code and test. The idea is to test functions and procedures. It's important to try to test at least once the functions and procedures on the code, and to keep the scope smaller so it's easier to write the unit test, and also to fix errors that we can see running the unit tests. Okay, so ideally unit tests need to be isolatable, repeatable, automatable, and easy to write. Before talking about guidelines, it's important to remember you about black box testing, white box testing, and gray box testing. Black box testing is for you have the requirements and you know the output, and the test you use these both things to test the requirements and the output. You in a black box testing, you see if the output matches what is necessary considering that requirements. A white box testing, here we test the functional behavior. We need to see inside that method and check if the structure are designed, well designed, and the code do what it's meant to do. And gray box testing is we do test case, risk assessment, and test methods on this type of technique. Okay, unit test, we can have all this on unit testing. Well, about guidelines. First, we need to keep unit tests small and fast. We will run lots of unit tests on the components when we have we will be developing and coding and also coding tests. So we will have many unit tests. So each one needs to be small and fast. If not, we will spend too much time running these tests, because the idea is that before doing a merge request, first, the dev needs to implement unit test for the new things that he is doing. And second, before creating a merge request, the dev needs to run all the unit tests that are coded on the system to guarantee that he is not breaking anything. So we need to have small and fast tests so we can not spend so much time doing that. And unit tests should be fully automated and non-interactive, because we need to give a command line, and this unique command will test everything. We run every unit test. This is important for the dev to run the test before doing a merge request, and also in our pipeline to run all the unit tests. We need to make unit tests simple to run. As I said, using a single command to run all of these. And it's also important to measure the tests applying coverage analysis. We are doing this on our pipeline. We don't have code many unit tests yet, but we have coverage analysis already on the pipeline. It's important so we can improve the coverage. We see what's missing and we work to improve this. When we see a failing test on the pipeline, or when the user run it locally on his machine, not user, sorry, developer. So when the developer run it in his machine and see the some test that is failing, it needs to be fixed immediately, because we have usually the test fails on a code that is recently done. So we have this fresh on our mind, and this can be fixed fast. And also, if the failing test was seen on the pipeline, it's even more important to fix it, so we cannot disturb the work of other developers. We need to keep testing at unit level. We are not, as I said before, we are not testing the workflow. We are testing just a method or a function. It's small, and it needs to be small, easy, and fast. We are not testing the interaction between methods or the workflow of the system. The test needs to be done at the unit level. It's important to main test properly. Sorry, I skipped one. Keep test independent. This is too important. And this is too difficult to do. Sometimes we have interaction with a database or with a structure that is related to another class or another in other space. But we need to keep test independent. So if we have, for instance, if we have an input in a file, the idea is to code that input on the unit test. The idea is not to rely on external dependencies. We need to, it's important to keep the test independent. Name test properly, it depends on which language and framework we are using. There are different guidelines to different language, but usually there is a guide to name properly. It's different from language to language, but it usually has suggestions. So it's important to us to keep that in mind when naming the unit tests. And also to keep tests close to the class or file being tested. The idea is not to have a directory and put all the test codes there. That's not the idea. The idea is to keep the unit test file on the same directory and near the class or the file that's being tested. Actually, we can discuss this, okay? It's not true. I'm not saying true. What I'm saying, it can be discussed. It's guidelines, but we can see what fits better for us. Okay, it's very important to test public API. So if we have a class, we need to test all public methods on that class. We can test private methods also. We can do that. But usually we test all the public API of that class. And the idea is to test each feature once. We don't need to waste time doing same test twice. It's important to use explicit asserts to guarantee that the output of the test is okay with what we want. We use assets to analyze the result of the tests. it will be clear. This part will be clear on the examples that I will show. Here it's we don't want to connect to predefined external results. As I said here, it's important to keep tests independent. So we can and we should use stubs if we need to use a class or a structure or a database, anything that's external to that class or file. We need to implement stubs. I will show an example of stubs also. And as Kabir said, when we saw a bug, when someone reports a bug, when we saw a bug, it's important to write a test to reproduce that bug and then fix the bug. And this test will be part of the unit test framework. About black box and white box tests, when we are implementing a unit test, we need to think as a consumer or a client and test if the class met that requirements. This is a black box test. We can implement it on a unit test. But we can also implement white box test because usually the developer that implements the code also implement the test. Even better if he first implement the test and then implement the code. Basically, the black box testing, it can be coded that way. We implement the test because we have the requirements and we know how the output need to be. So we can implement a black box test before implementing the code. And we can do white box test also to test internal structures or complexity or functionality inside the method. And it's important to test trivial case too, because they can have errors usually when we copy and paste operations. We now, especially when we are creating unit tests for a component that already exists, we need to focus on execution coverage first. We need to keep that in mind so we can create that unit test for components, especially one that already exists. And here's some ideas to do test covering about the cases. For instance, number, we can test negative, zero, positive, smallest, largest number, etc. If we have strings on the parameters, we can pass empty, single character, non-ASCII, big strings. If dates, we can test dates on limits. And it's helpful to have a handle generator so we can pass this boundary case, the data for this boundary case easily. But this is a guideline. We don't need to do this on the beginning, but it's a useful thing to think. Now let me show some real examples of unit test. Okay, here is the project is DAS from SingularityNet, and we have some Python files here, and we can see that, for instance, we have a metalex by file and together the metalex test by file. This here, this unit test here, it will use PyTest to run it. PyTest, we can give that command PyTest on the root directory of the project, and the PyTest will look for all files that have this extension underscore test.py, and the py test will run all the tests inside these files. Okay, so that matches that idea to have a single and a simple command to run all the unit tests on a project. I will show you this metalex test.py here. Here, this piece of code here shows the idea of independence. Here, it's necessary to run this test. It's necessary to have an input from a file, and then the dev code here that input to not have a dependence from an external file. So this structure here, it simulates what is in a file, but it's here inside and here is a function that has tokens that are expected after running the test, and the test is simple. It's basic to use this input, and to loop in all these expected tokens to see if all they are gone. If all they met the result of the method. So, and here we have the assert instruction that I said it will be clear when showing the code. Showing an example. Here, this assert is saying that the token type needs to be equals to expected token. Okay, expected token is here on this structure, and the token type is the output of the test. Okay, if they are equal, the test passes. So this is a simple example of a unit test for this text lecture. Okay, here is the lex. Now I want to show the test for this metalex YAC. Okay, here is an example of a stub. This parser action is a class that's not inside the meta YAC. It's an external dependence, let me say like that. So here, the dev creates an action broker to be a stub of this parser actions class. Okay, and the stubs need to be simple. Here we can see that these methods, actually we have to implement the public API, I mean the public methods on this class. And you can see that we need to have a simple instruction, so we cannot add bugs on that. We are testing. The idea here is to test the meta YAC, okay, not to test the parser action. So we do a stub with simple instructions, and we use this stub in the tests of the meta YAC file. This is an example of a stub, and we need to test all the public API of this meta YAC. And here's another example. What I want to show here, that let me remember. Yes. Here on this file, I want to show you that we need to keep the test simple, but it doesn't mean that we do it in a rush. A good test needs to be designed thinking what we want to test, if all the possibilities are covered. And here is an example of a test that have some inputs and many sessions. And sometimes we need to design the test. We need to think in a good design so we can test all the possibilities. And sometimes we need to create structure to help doing that test. And this is here, for instance, we created, let me show you here. We created two methods to be used here to make it easier to do this test. The dev create the check pattern and get items. Get items is used only here, and check pattern is used in this unit test to make it simple and to not repeat too much the code to run the test. Okay, and this I try to give you an idea about how to code a test. For instance, this that is a Python code. I know that this was too fast, and we need to get more knowledge about unit testing, but the idea is to give a north, to give some a background to start doing that, to show some real examples and talking about guidelines, so we can start implementing the unit test in our measure requests. Another thing is that to start doing this test is difficult because we don't have many things in place. So coding the first unit test is time consuming. We know that we will probably have an issue for the main components to implement this first unit test, because we need to set the basic framework to do that. And that stubby class that I mentioned, we will be implementing this stub test during our development. And in the beginning, we will need to do more stubs because we don't have anything. But we can do these stubs in libraries. We can add these to libraries. So we can use these libraries, this stub in the libraries when we are implementing new unit tests. So this will make things easier in the future. In the beginning, we will probably need to implement some stubs, and this will take some time. Okay, I think this is what I have to show you. Any questions? Does anyone get something related to frameworks that we can use, as Dagin suggested on the daily yesterday? Well, for Python, we have PyTest, and I think this is what we will use. As I show you, the idea is to have underscore test.py and implement the unit test there, and the PyTest command will run all the files that has this type of extension.